So let's look into the theorem which is associated with the word subtend. Equal chords of a circle subtends equal angle at the center. Okay, let me explain it this way. So you have a circle with center O. I have two arcs. Say this is your first arc, and say this is your second. Sorry, not arc. What is this? Chord. So AB and PQ are your two chords which are of equal length, and this is the angle subtended by this two chord at the center. Okay, so you can call this as theta1 and theta2. So what they are telling is theta1 is equal to theta2. So let me actually write everything and prove it as well. It's not too hard, so I'll prove it here itself. So we have been given AB and PQ are two chords, and these two chords are equal in length. Then we are taking let theta1 be theta1 comma theta2 be the angles subtended by the chords at the center. Okay, then what is that we need to prove? So we need to prove that theta1 is equal to theta2. Okay, so proof is very simple. Consider triangle OAB and triangle OPQ. Okay, so remember these two lengths are equal. That's your first clue. PQ is equal to AB. Then your second clue is this is given. Second clue is OA is equal to OQ. Why? Think about it. And even OP is equal to OP. Why? Because these are radius. Okay, and so therefore by SSS congruency triangle OAB is congruent to triangle OPQ, right? So this implies theta1 will be equal to theta2, reason CP CT. Okay, so clearly we can see that angle subtended by any chord, you take one more chord which is of same length, the angle made by them, those chords, will be of same measurement. Okay, again this is with respect to the center, and there are a few other theorems with respect to the major arc, minor arc, so on and so forth, that you will be learning. So this is your theorem 1. On the same lines we have the converse of this. Okay, so the theorem again here is the same thing, we just need to prove that they are congruent. The second theorem is if the angles subtended by the chord of a circle at the center are equal, then the chord is same. I mean, not same, they're equal. So same thing, you have two chords, that's your center. Again this is your center. So we have say AB, PQ, and this is O. Say this is theta1 and theta2. Here we have been given, I won't describe the diagram and all, I'll just write given chords. They're not equal chords by the way, they're just chords. PQ and AB, they subtend theta1 and theta2 angles respectively with the centers. In the center, not centers, center. So we need to prove AB is equal to PQ and theta 1 is equal to theta 2. That's one more thing that is given. Now, how can we prove this? Again, quite simple. Consider triangle OPQ and triangle OAB. Here OP is equal to OB. Reason? Angle POQ is equal to angle AOB. Reason? And OA is equal to OQ. What are the reasons? Here the reason is radius. So this is the given, and the other one is also radius again. Therefore by SAS, or is it what? Or is it something else? It's SAS itself, right? By SAS, triangle OPQ is congruent to triangle OBA. And so we have AB is equal to PQ, CP, CT. I hope you guys got the difference of both the theorems, right? It's not that hard actually. Okay, so useful theorems, easy theorems. So learn the proof also. Actually, I hope you guys already learned. It's nothing much. So try to do all of this writing on your own. Just copy the theorems and do the rest on your own. So these are set of things that you can do it at once. At one go and once, and you are done. You need not do it again. Right? There are things which you need to repeat. I agree, but these are not those things. This is very simple.